Well. Good evening, everyone. How are you tonight? Good. Glad to hear it. Lovely weather we've been having lately. I've even seen the sky a couple of times over the last little while. Last weekend. Oh, yeah. Last weekend I was down at Rideau River Park, spent the weekend down there. Pretty nice skies for, being that close to the city. I think it was mostly starvation on my part, but it was pretty cool. I got out in the middle of the night. No binoculars or anything like that. Just lie on my back on the grass and take it all in. It was wonderful. Anyway, before we get going, at the end of the last meeting last month, while we were cleaning up, someone's little tan-colored notebook turned up. So if it's yours, if you're missing it, it'll be up the front here. You can come pick it up later, okay? So, without further ado, welcome to the August 5th edition of the meeting, the monthly meeting of the Royal Astronomical Society, the Ottawa Centre. I can see there's a fair number of people in the seats there tonight, and as is customary, anyone here for the first time tonight? Yes, okay. The usual ones that are here for the first time every time. Okay. So welcome. For any of you who really are here for the first time, welcome to the meeting. We always love to have new people drop in. We don't require that you be members. You're more than welcome to come and attend and listen in on what we're doing for as long as you like. We'll probably eventually come to recognize you and start to bend your ear about the benefits of being a member of the society. But in the meantime, you can just kind of hunker down and pretend you've been here for years, and maybe nobody will bother you for a while. Okay, so next please, Heather. So I'll point out right away, you'll notice that Chris is not here this evening for the first time in gosh knows how long. Chris has just this morning had some further surgery on his elbow. You might know that it's been bothering him for a while. So I think he's at home recuperating right now. And his daughter, Heather. Thank you, Heather. Heather has been volunteered, I'll say, to come down and help. She's graciously agreed to come and help out with things tonight. So if things seem a little different tonight, relish it as an opportunity to see a new and different way of doing things. How's that? How am I doing so far? Okay, so tonight's program should be an interesting group of stuff. We'll start off with 10-minute astronomy news, and for a change, Neil Rowlands is stepping in tonight to take care of that. Next, we'll have a first-time presenter here, Peter McLean, talking about shooting stars, not meteorites, but very high-velocity stars. We'll follow with the observations in the first half this evening, and then after the break, we have Guylain Rochon, who has a software product called Backyard EOS for controlling Canon SLRs, I would guess by the title, has been invited in to show us his software and how it can be applied to what we enjoy doing in the middle of the night. And then Mike Mogadam, who's just back from his visit down south, has come back with some video and some slides to tell us all about the final launch of Atlantis, the last flight of the space shuttles, and then he's going to give us an outreach update. So it should be an interesting and full program tonight. Next, please, Heather. Okay, so we'll start off with Neil Rowlands. Welcome, and thank you for taking this on tonight.
Okay, well, I'm filling in for this presentation, but as usual, there's a lot going on, so hopefully I'll keep it to 10 minutes, but I did try to whittle it down, so we're just going to focus on a few things that I thought struck my interest, hopefully yours as well. So we have basically, which one is there a laser on this?
Yeah, the center button.
Center button, okay. So we have the discovery of an Earth Trojan asteroid. We have some news from the Hubble We've got some, just an item I picked up on weighing of galaxy clusters, and then there's a fair bit going on in solar system exploration, including the launch of Juno at 12:30 today. So, and some pretty neat stuff coming in from Dawn arriving at the asteroid Vesta. So all fresh, brand new stuff, and it's all pretty good. Okay, so this is made the cover of Nature, prestigious science journal, on July 28th, and it's a team of Canadians who made this discovery. Actually, the asteroid itself was discovered by the WISE, the Wide Field Infrared Survey Explorer satellite, in October 2010, and but it was Martin Connors at Athabasca University who determined that it was co-orbital with the Earth. Now, there have been other I think there's two other asteroids that are actually co-orbital. In other words, they follow the or precede the Earth in its orbit around the Sun. But this one's a little different in that it is actually locked into a resonance. In other words, it stays around the Lagrange points, which are gravitationally kind of quasi-stable points, and they're shown here on the bottom diagram, the L5 and L4 points. So what this what this new asteroid is doing, what they were able to determine a much more precise orbit with CFHD images. Christian Billet, director of CFHD, used some discretionary time to get some images, and then at University of Western Ontario, Paul Weigart calculated the orbit, which was no small feat because it's a very complicated orbit, as you'll see in a minute. So, initially when I thought, a Trojan asteroid, Jupiter has them, they just do what is in this bottom diagram here. The asteroids, those white dots, just cluster around the Lagrange points and then just follow the Earth or precede the Earth as it goes around the Sun, just like the Jupiter Trojans follow or precede Jupiter around the Sun. But that's not quite what's going on here, and this little movie will demonstrate. Maybe we can start the movie in the corner. Just click on the... So this is the Paul simulation that goes through. The Earth is at the bottom, the Sun's in the center, and this is, you can see the year counter going on there, and the blue dots are just Earth's orbit. And with respect to the Earth, this thing is oscillating back and forth. The off-orbit distance is exaggerated here, but not the distance that it's moving around the Earth's orbit and back. So with about a 390-year period, it's oscillating back and forth. So it's going quite a ways. It doesn't just stay around the Lagrange point. Anyway, it never gets any closer than 20 million kilometers to the Earth. But what I found really interesting was that this actually, they calculated the orbit backwards and found that in the year 500 AD, it switched from doing this motion around the L5 point to doing it around the L4 point. So I had no idea that these asteroids behave this way. And there's similarly complicated ones for the other two, the other two co-orbiting asteroids around Earth. So Earth has these three unique partners on its orbit through this, in the solar system. So next slide. So in Hubble news, just happened to be, I guess, that the millionth observation occurred on July 4th. Funny how the coincidences happen that way. But it's like the millionth customer at Walmart or something, right? They just decide to set it up. But it is a milestone. Hubble has been making many observations, and in this particular observation, chosen to kind of highlight what it can do, is looking at an exoplanet. It's a hot Jupiter. It orbits with a 2-day period around the star Hat P7, so it gets the designation 7b. It was discovered in 2008 by the wobble in the, just watching the spectra of the star and seeing that there's a small Doppler shift in the star. That's how they discovered this. But Kepler actually found out that not only does the planet, tugs at the star, but it also passes in front of the star. And you can see that in the plot here, this smooth curve, as the fairly large planet, it's a little bigger than Jupiter, orbits this star with a 2-day period. So that's good. But what was interesting is the smoothness of that curve, and also the fact that it, as you get up to the top, it's not flat topped. And it basically meant that just from that curve, they can tell it's got significant atmosphere absorption. So Hubble's coming along with the new instrument that's been refurbished, the Wide Field Planetary Camera 3, and it's going to do spectroscopy of this star. That data was collected, but apparently it's going to take months to really interpret it. So they're getting spectra over that period, and hopefully we'll be able to extract what the composition of this planet's atmosphere is. Maybe they'll detect water. That would be a first. It would be more like steam, because I think the planets are about 2300 Kelvin, because it's so close to the parent star.
Excuse me, Neil?
Yep.
What did they classify as an observation for Hubble? Because 1 million, that's, in how many years has Hubble been up there?
Well, 91, was it?
Yeah, 20 years?
20 years, yeah.
Yeah, so 1 million observations, if you do the math on that, boy, they'd have to be banging off observations at a great rate of knots. Would it be like enough, if they were photographing something, like every close of the shutter type of thing would be an observation? Any idea of that?
I think it probably means a repointing of the telescope to a new object. And that would happen frequently for numerous reasons. It might even, I don't know if they're counting the, every time it orbits, it can only stare at a single object for 45 or 60 minutes or something, and then it has to be retargeted because it goes around, it's in low Earth orbit. So if they're counting that, then certainly you can get up there. Yeah, but then they'd call it orbits, I think. So, yeah, I don't know. It does seem like quite a lot. But on July 20th, it made another observation, and it found a fourth moon of Pluto. And it's just from images taken a week apart, and there's a small dot there, P4 it's labeled, hasn't got a name yet, and probably has a diameter of 13 to 34 kilometers at the moment. So, next slide. So in terms of other news, there's a conference going on in Liverpool, and basically people are trying to weigh the biggest objects in the universe and keep track of all the mass. And the biggest gravitationally bound objects are clusters of galaxies. And you can use various methods. There's a visible light image shown there. The data on the left is from the Planck satellite, and that's going to generate interesting new results for the cosmic microwave background. But in addition, beside the background, you can see the galaxy in this view, but you can also see a lot of extragalactic sources. So that sub-millimeter or far infrared observations can also be used to kind of get a handle on the mass of these clusters. And then the other method is X-ray observations. Anyway, apparently you can get two of the three methods to agree, but the other one never fits. You can't get all of them to fit together. So it does cause a problem, and it just goes to show that where astronomers are still embarrassingly short of accounting for all the mass in the universe, and this is just one of the problems they're facing. So, next slide. Moving on to the planetary exploration side of things, on July 22nd, also the NASA, the Curiosity rover, also known as the Mars Science Lab, MSL, they finally selected their landing site. The craft launches November 25th. And it should land August 2012, and it's mainly about going after conditions that might have been favorable for microbial life, sorry, and for preserving clues about that life in the rocks. So it's actually a very capable rover. It's about 10 times more massive than the Spirit or Opportunity rovers. So they're using a totally different method to land it, which will be interesting. The other thing they're doing is, I found interesting, they actually, notice it doesn't have any solar panels. It's using a radioactive heat source that'll turn into electricity. It's just due to the decay of plutonium. So I'll talk about that more in a minute when we get to the next thing. But in terms of choosing the landing site, they wanted a place where there's evidence of water, evidence of sedimentary deposits, and apparently that's in this Gale crater here. And it's about 150 kilometers in diameter, and it's a very tall mountain. But there's some layered deposits that they can see from orbit in that circle, and that's the landing ellipse for the mission. So the rover should touch down there in next summer. So. Oh, and Canada provided the alpha particle X-ray spectrometer, which is a little instrument to actually basically take the fingerprint of the minerals. It exposes the rocks to some radioactive sources, and then receives X-rays back. It detects them and can tell what concentration of different minerals there are. So, exciting mission once it happens. Next one. And then the Juno mission launched 12:30 today. And this is interesting, getting back to the reference on the other slide. This one has a lot of solar panels. That's because, at Jupiter we have about 25 times less energy from sunlight than we would around Earth orbit. And all the missions to Jupiter and beyond have used radioactive isotope generators. This one doesn't. And basically, they came up with a low power, suite of instruments is one way of doing it. But the other way, it turns out that these radioactive isotope generators, there's actually a limited supply of the plutonium for them. So they have to be a bit careful on what missions they go on. And this was deemed to be a fairly small, fast turnaround, fast development mission. And they didn't want to take on the expense of those generators. So I found it ironic that they're actually using it on the Mars rover, but not for the outer solar system. And they have to do great lengths to protect the electronics from the intense radiation around Jupiter. Next slide. And then, of course, Dawn entered orbit around Vesta, for Vesta, the fourth asteroid to be discovered. And it happened on July 16th, although they're not exactly certain of the time, because they're not exactly certain of Vesta's mass. Hopefully that'll change as the mission goes on. You can see an artist's conception there. It's a different sort of mission. It uses ion propulsion, so they can do a lot with this. In fact, after Vesta, it's going to go on to Ceres, the first asteroid discovered and largest. And that won't happen, I think, until 2015. But in the meantime, it's going to spend the better part of a year going around Vesta. And here's a color map showing the what they get from infrared images. It'll tell them the particle sizes and the regolith. It'll tell them the mineral. But right now, it's a pretty picture because they haven't calibrated the cameras that well. But that'll change too. And there's a great image there. And the next slide has the movie, which is really cool. Watch for the grooves around the equator of Vesta. My laser's gone, but there in the bottom left and rotating up to the top right, you can see those grooves. So nobody's got an explanation for them yet. But this is the NASA official video. It's a bit choppy. Amateurs went out and put another version on YouTube. If you want to check it out, it's kind of more smoothly rotating, but not quite as accurate when the objects come off the limb from the dark to the light. So, I think that's pretty exciting. A first look at a really good look at an asteroid from the main belt. And that's it. Thank you.
All right, thank you very much, Neil. Please welcome Peter McLean.
It is working now. Center button for the laser and the side buttons.
Okay, to go forward and backwards? Okay, terrific. Excellent. Thank you very much. Well, this is about not so much about the meteorites, as Bill had pointed out. I actually got interested in this because of the wisecraft that Neil had mentioned just earlier. It's very interesting. And do I point somewhere, or?
I think you just press the right button. It'll work. No.
Just say next slide, please.
Oh, okay, I gotta go like this.
Don't point at the screen.
Okay. Okay, these are basically stars that are traveling through space at incredible speeds. And there's one they're suspecting it's up to 15 million kilometers per hour. And I got interested in this when NASA released an image in March of one of these stars, the first one there. And the rest of these here, I actually went into just to do some research to see just how widespread this phenomenon is. Now, these are incredibly fast stars traveling through space, and they're actually doing there's a phenomenon called the bow shock wave. I don't know if you've heard of it or not. I think it's pretty cool. So here we've got this. This is a supergiant, and you've got here this. This is the star here, and this is a huge, almost like a half dome around this star. What's happening is that there's a solar wind coming off this star, and it's coming out all around the star. And what it's doing here is it's actually pushing out all of this debris. And the solar wind is burning the electrons off of the particles, and they light up. And the WISE spacecraft is able to detect that in the infrared. This is a supergiant, and you can see the speed here. It's somewhere between 2.4 million and 15.1 million kilometers per hour. They're having a tough time gauging just how fast this is going.
That's a really big gap.
Sorry?
That's a really big.
Yeah,
span.
absolutely, absolutely. Why these stars are traveling so fast is normally what happens is you get a dance of two stars in a binary system. You remember the Titanic? You got Jack and what's her name holding hands, and they're going around like this. One of them blows up, and the other one smacks into the wall. So that's basically how this happens. So this is what a bow shock wave is. So the star is giving off a very strong solar wind. The solar wind plus the forward direction of the star, as that star is moving through space, they combine together to push all of this debris in one direction. And it's called a bow shock wave basically because of the, if you look out the front of a boat, you see a wave, okay? And it compresses the interstellar gas and the dust, and it causes it to heat up and to glow in the infrared. This is just a little simulation. You see here this is the star. This is the solar wind blowing out, and as it moves across, it pushes it out like this, and you can see the comparison here of what's happening. You got this kind of shape here. Okay. Now this is not just with this one star. There are actually about 19 of these stars that they've identified so far. This is Zeta Ophiuchi, and you can actually see this one towards the south at this time of the year. It's a very massive blue star. It's traveling at about 86,900 kilometers per hour. And again, this is a case of it was once a binary system. The other star probably exploded, and this one was left to shoot off. And I think actually for this one here, the other one, they've identified it. It's not completely exploded. It's now currently off in another constellation somewhere. Because this
Why
is a
is the
very...
speed so precise on this one compared to the other one?
I think it's probably because of the angle that it's traveling. But I'm not sure. I mean, it's not easy to actually find this information, but I think it's probably because of the angle. And there's another one, the next one after this, they don't even know how fast it's going, because it actually looks like it's heading in a direction towards us. But again, it was freed from a vanishing partner, and this type of star only lives about 8 million years, and it's halfway through its lifespan right now. You can see here, you can see all of these wisps, and they're all in one direction, like this here. But the star right here was coming up like this and completely distorted this whole cloud here. And you can see how that's taken effect. Menheb, this is another massive blue star. Again, they don't last very long. It's incredibly hot. And the gas, you can see this is the bow shock wave here. And it looks like it's actually coming from back here and forward into this kind of a direction like this, if that was like a 3D. It's not very far away. It's only about 1,800 light years away. They can't get a speed or a cause on this one because if it's coming at an angle like that, I imagine they're having a hard time really gauging the speed of this one. This one's a little bit different, with the rather unpoetic name of HE and then a bunch of numbers. This is probably a blue straggler. These are two stars that merged together, and now they're absolutely huge. This one's traveling at 2.6 million kilometers per hour. Now there's two theories as to what's going on here. The first theory was that this actually had initiated within the center of our galaxy, and this star was actually either in a dance with another star or two other stars. They got too close to a black hole. The black hole gobbled them up and left this star to come firing out by itself because it still had momentum, but it needed to exercise that momentum in some direction, so it just took off. It's out in the middle of nowhere above our galaxy. There's nothing out there at all. It's actually 200,000 light years out. Now this is the thing. The reason why there's two theories is that this first theory, they're not too sure about this now. This star is only about 35 million years old. This is what they think now. But in order to get where it is now, if it had come from our galaxy, it would have taken 100 million years. So if you do the math, that doesn't work. The other thing is that all stars in all galaxies, they all tend to have some sort of a fingerprint that they belong to that galaxy. Now this is, I'm not going to get into physics and all that because I'm not a physics expert, but what I've been reading, when they look at the fingerprint of this star in our galaxy and compare it to the Large Magellanic Cloud, it seems to have come from the Large Magellanic Cloud. So it's not from our galaxy at all. They think it came from there. When you do the math for the LMC, that it has traveled from the LMC, scientists believe that that's a much more credible explanation for where this star actually came from. That's the star there. This was taken by the Hubble, also in the infrared band, but you notice it doesn't have a bow shock wave. And I think that's just to highlight the fact that there's nothing out there. There's nothing for it to hit. It's traveling at, what was it, 2 point some kilometers per hour in the middle of dead space, and there's just nothing for it to hit. This is the last one. This is Myra. This is kind of interesting because it gives scientists some unique opportunities. This here has nothing to do with this, but you see a long tail, and that's the star there. And you can see right at the end there's a bow shock wave. It's hitting a lot of debris out there, and it's just smashing through all of this debris at almost 500,000 kilometers per hour. It's a red giant, so this is a monster. If this was to replace our sun, this star's surface would be basically where Mars is right now, Mars's orbit. So that's pretty huge. Now the tail is 13 light years long. So the distance from here to about here would be the distance from our sun to the nearest next star, Proxima Centauri. So that's a huge distance. And another thing about this picture is that if you were to do a spectroscopic analysis of all of this, you can actually look at how this star has evolved over the many, many years. You could see, well, there's maybe a lot of helium here, and then there's helium and hydrogen, maybe argon, and sort of track it like this going across. This is a little video that I put together. No, NASA put this together based on that diagram to show you basically what's happening with that picture. It's pretty cool the way they did this. So do I have to hit something here?
Yeah, just click the next slide.
Just click again.
Or not.
There we go. Oh. Okay, so you can see this is the solar wind on the outside. Now you see the bow shock wave. It's almost like a concave dome right around the front of that star, and you see the trail here behind it. The tail releases about 10 Earth masses every couple of years or so. And that's how they got this picture. And I think that's just a summary of what I've shown you here. Right now you can see the Zeta Alpha Yuki is available. You can see that one. Some of these you can't see, and in fact Myra is really tough to see. You can't see it from where we are. You have to be south of 20 degrees north of the equator to see it at all. But you can also see the different speeds, anywhere from 54,000 miles per hour. That should be kilometers, by the way. I know I converted that. Up to, and that's 15 million kilometers per hour. And the different causes for them all. Is there anything else?
That number there, HE, that's the coordinates of it. That's 4 hours, 37 minutes minus 54 degrees, 39 minutes. Because it's in Dorado. Dorado's down near the South Pole.
Yes.
So that's the coordinate number.
And HE is the initials of the lead
Well, that
scientist.
could be Hubble or something
It's,
like that. But that's the coordinate, what they call coordinate numbers.
Yeah, okay, excellent. I didn't know that. That's good, thank you. And this is Heinz Edelman, I think is the guy's name who discovered this. It wasn't for very long ago either. And that's it. Thank you very much.
Good. Okay, we'll go straight over to our observations segment for tonight. Where's the control? There we go. Okay. I'm going to give it a try, see if I can mess it up too. Works perfectly well for me. Okay, so Mike Earle's not here, but I guess I'll speak to this first one anyway. Mike contacted me just a short time ago with his most recent accomplishments. Those of you who have been here for a while, which I think is most of us, except for the newcomers we saw tonight, are familiar with Mike's mission to photographically record as many satellites as he can. And from time to time, Mike will come by and he'll keep us posted on his achievements and how far he's gotten. Well, he has another report, but tonight he's not up here, and he sent us a couple of slides, and I guess I'm to speak to it. Anyway, we're going to go through Mike, Paul, of course. Eric has got an observation, Rolf, Bob Olson, and Gary Boyle. So to start with, Mike's. This is a familiar slide to those of you who have been following Mike's exploits over the last couple of years. His current score overall, amongst all these different types. Let me see, is it working? Is it? No, it's not
You're
working.
advancing the wrong computer.
Pardon me?
You're now advancing the wrong computer. Give me 1 second.
Okay. Somebody's doing something with the computer. Anyway, Mike is basically trying to record as many as possible. I'm not sure how he stands internationally as far as, his score with respect to anyone else, but it sounds pretty high to me. His current total, just over 4,000 satellites photographically recorded, which he reports is just under 25% of the total number that are up there right now. In particular, he's very recently recorded one of the oldest satellites. I believe it's the 4th oldest that is still in orbit, the Explorer 7. You can see the little streak he's got here. I don't know if you can see the laser on the light screen, but his recording of it, and of course this is the satellite before launch. He's also got one at very long distance away. I think this one he notes in particular because of its distance, and you can probably just see it moving here. 189,360 kilometers, so fairly high orbit. And that's it for that one. Next up, Paul Commission.
This is Able 12. It's a planetary nebula that's located in Orion. The magnitude is 13.9. The size is 37 minutes. The center star in there, if you can see it, is a 19th magnitude. That's pretty dim. Now, you notice it took me 3 minutes. The thing is that I tried various shots on this. You've got a very bright star interfering with a rather dim planetary. So if you cut the time down, the planetary doesn't show up, but the star does. If you go beyond 3 minutes or so, then the star overpowers the planetary. So it took a lot of work. Sometimes stars, I hate to say this, interfere with your good observation of deep sky objects. This is a perfect example where this is an object that is fairly nice and all this kind of stuff, but you got to be, even here I got, as you notice, the thing started to bleed a bit. So it's very difficult. Sometimes these objects are very difficult to photograph because of the closeness of bright stars. Now this is called Able 12. George Ogden Able discovered this one. Next, please.
Paul, before we go over, do you have any idea why the asymmetric spike on the one side here?
I don't. No, that's one of those things with the with the machine or with the telescope? I don't know. Yeah, that's a good point. I never thought of that. It's on one side, you're right, and not on the other. But you notice how close the star is to the thing. It's one of those. It's one of these that you have to spend a lot of time to get it as best as you could. Maybe somebody that's better here,
Okay.
Could do a better job. But that's as good as I could get it.
Was there a comment back there on it?
When you get a very bright star in the field of view like that, a lot of the cameras, the electrons that collect in the wells in the individual pixels actually start to bleed up the camera. And so that's why, and they always bleed in the direction that the camera reads.
Oh, so that's going to be a characteristic of the detector more than anything else, huh?
Yeah.
Oh, okay. So, I think you said next, didn't you?
Yeah, please. This is Able Galaxy Cluster 262. A friend of mine told me to photograph NGC 705, which is the one right there. That's right, yeah. And it's a 14th magnitude galaxy. This galaxy cluster is in Andromeda, and it's if you have a 12-inch telescope, you'll probably see this, a pattern of it. It's quite a large thing. It's very nice. There's a number, as you notice, there's a number of there's a number of them of the galaxies that are face on. But some of them, as you see, are on edge on and all this kind of stuff. Well, these things happen. But this is an interesting thing. It was something I wanted to say. These Able Galaxy clusters were discovered by a fellow named George Ogden Able, who was a professor of astronomy at the University of California. And he didn't discover these by sitting on mountaintop and taking pictures. When they 48-inch Schmid, the pictures came out there. That came out. What he did just before the public got a hold of them, he took a magnifying glass and went all over these things and found all these things. So he actually bootlegged. How should I say? He didn't actually discover them in the sense of being on the mountain. He discovered these by taking a magnifying glass and looking all over the shots. So that's one of the things that he's noted for. He's passed away now, but he was very astute in his observations. I wanted to say a word, if I can, if you don't mind.
Sure.
I think that we're going to see a lot of backlogging and things like that. Now with this American Senate cutback thing, I forecast that things like the different things that'll be on the agenda, they'll be put back and put on ice. I think a lot of that stuff is going to be how should I say, delayed, tremendously delayed or put on ice. All their things, Webb telescope, all these things. That's a guess, but I think I'm going to be right. With this cutback stuff, you'll see NASA suffer very deeply.
So probably astronomy will go back to the magnifying glass and the existing
Exactly,
photos, huh?
yeah.
You bet.
That's right. The amateurs will be the ones.
You bet. That'll be it. Thank you, Paul. Okay. So next up, Eric. Here we are. There you go, Eric.
That's actually the last slide. There's the first slide should be the Brent crater.
We only have the one in.
Oh, we only have the
Yeah,
one
you only
slide?
put it, let me put it in as an observation. That's it.
Oh, okay. Well, I'll have to do Brent next month.
Okay.
Hello, everyone. Before I talk about this, I just want to mention that 34 years ago, I had a debate with a schoolmate about whether or not there was an asteroid orbiting the Earth. And I said no, and he said, yes, I think there is. And so what I did is I wrote to JPL, to NASA, and asked them. And they said, nope, there's no asteroid orbiting anywhere near the Earth. And now I'm going to have to find this fellow and tell him that he was right. Sort of. It's sort of orbiting. I want to talk. I was going to talk about Brent, but I'll talk about it next month because I don't have the slides here. But I had the opportunity to visit Nirvana for the first time last weekend. It was ideal conditions. And where's the pointer?
Right here.
Okay. So most of you are familiar with Nirvana. It was my, I'd actually visited it sort of when I took this picture a year ago when I went up with Chuck. And this time we planned a summer camp to Bon Echo and took advantage of Nirvana being close to visit it in that time. And so, how does that work? There we go. Oh, did I lose my slide?
Go left.
Okay. Can you bring it back?
There you go.
Okay.
Big center button.
There it is. So Bon Echo's down here. This is Lake Irvine. This is Highway 41, and there's the access road that comes up. And I decided to camp for a night right in here. Apparently, Friday and Saturday night, Sanjeev and Pierre had visited, but on Sunday night there was no one there. I had the whole place to myself. Gordon Webster came. We were planning on observing together that night, and I just wanted to give you a few general impressions of the place. It's clean, easily accessible. Just a perfect site to do observing in. I'd never seen a site like this. And once I set up camp, Gordon showed up with the telescope and we set it up. And a few objects that we had a chance to see were the Veil Nebula, which I think most of you are familiar with. One thing I should do is bring prints of the objects I want to look at so that I can compare the prints to what I'm seeing through the viewfinder. And so I'll be doing that next time. And also to record my observations orally, because there's so much to see and you don't want to spend all your time writing stuff down. So I think that's what I'll do there. But I got to see the Veil Nebula, and no color obviously through the viewfinder, but the shape was very apparent. M81 and 82. And one object which I hadn't seen before was Mirac's Ghost. This is a star that has that's right. There's an object adjacent to it, makes it look like a ghost of that star. The photographs don't do justice to the intensity of the color of that star. It's a very yellowish color, and I tried to find a photo that came even close, and no. So visually observing, you appreciate things in a different way. And we also saw. Does anyone know who the companion galaxy to M51 is? Because there were two galaxies that were interacting, and I had never seen that visually before.
NGC 51, 54, and 55.
It's 5194, 5195. 5195.
Oh yeah, 59.
Thank you. And Andromeda, of course, and several globular clusters which I hadn't seen before. And to finish off the evening for the observing, we looked at Jupiter with its 4 moons, all on one side. And what we noticed about Jupiter was that at Nirvana, it's actually too bright, that you can lose your night vision if you look at it and then want to see another object after. So that's the difference in the intensity of the objects in there. And once Gordon left, I was camped overnight, and I just looked up at the sky, and I saw meteors galore. It was fantastic. The Perseids are coming up. And something I never appreciated before was the different intensities of the meteors. I thought they all burned pretty much at the same brightness. And then I saw this and realized that we miss most of the meteors that shower in the sky, that we don't see most of them, certainly not from here or even the FLO, but at Nirvana, I could see a lot more. My final impression is you need to go. If you want to appreciate observing at its finest, go to Nirvana, bring if you don't have a telescope, find someone who does, and enjoy that experience. It's well worth it. And finally, I'd like to mention that today is Neil Armstrong's 81st birthday. Thank you.
Eric, can I ask you a question?
Sure.
I was at Stella Thing, and we had, I wanted to ask you about the darkness, like, when you go to observe, and this is a dark, the site was dark, we had like 6.3 or 6.4
Yes.
visual. But I'm looking at the sky, and it's gray. What color did you see? Is it black?
I saw
This is sort of like, no, it's.
I saw it bluish black.
Okay.
Is what I saw, more like very black, bluish black. There was also a lot of humidity in the air, so it wasn't quite the ideal conditions. I'm anxious to go in October, if possible, and you know, with a colder, drier sky, and also we have less daylight at that time. So that's what I saw there. Also, I should mention there were thunder, lightning storms off in the distance. So sometimes when we were observing, we'd see flashes, and but fortunately the clouds stayed away, so we had a clear sky. The other item I want to mention, I have never seen a satellite through my viewfinder before. Maybe that reveals how much observing I've done. Have most people who observe seen a satellite fly through their viewfinder? Yes? Oh, there you go. So I'm still a newbie, but I'm getting there. Thank you.
Thank you, Eric.
One more?
Yes? Don't you find the chemtrails are just destroying the night seeing? I find the chemtrails are just ruining the night sky.
The Kent trails.
The chemtrails. The global chemtrails, not chemtrails.
I'm not sure I know what you're talking about.
Continual spraying they've been doing for the last 10 years. Yet they were spraying today. They spray every day around the world. I find it ruins the vision. You can't see properly. You can't see the stars. No comment about
I've only been there once, so I wouldn't be able to tell. But that's something I'm going to look forward to. Just checking out contrails, eh? Chemical trails. Oh, from the jets. Oh.
That's a contrail. Chemtrails are the barium solution, the barium salts sprayed in the air, the aluminum being sprayed in the air around the world. It's the haze we see outside now. It's awful.
Well, I can only relate to what I saw at FLO, which I've been, and in the city here. And I still find it's a much better sky at Nirvana. And I'm sorry to hear if there are chemicals being sprayed in the air.
Okay,
We should
Eric,
do.
I think we need to move ahead with the other observations. Thank you. Next up, Rolf Meyer with his observations. Thank you.
I have a title slide. It's just my name. Okay, this is obviously Jupiter. So this is primarily showing the difference between, for example, 2011 and 2010. Interestingly enough, they were both taken on August 1st, the one on the right and the one on the bottom. These are the equatorial belts, and last year, the south equatorial belt, these pictures are shown with south at the top, as you'd see it in a telescope. And last year, the south equatorial belt was mostly missing, but this year it's come back, as you can see. There's no red spot, obviously, in these images for some reason. I missed it. Okay, so Jupiter, of course, is coming up in the morning sky, and you should try and watch for it. This is the Milky Way, kind of looking straight up towards Cygnus, which is up here, and this is the North American Nebula. Now, the Veil Nebula is down here, barely in the shot. I wasn't intentionally trying to get it or not. Can somebody tell me what these are? Because I don't.
I see stars.
No, actually, I'm referring to the red areas, which are not stars.
I see 1316.
Is this one object, or is this?
It's called the Gamma Cygni Nebula complex.
Okay.
And then there's a crescent down below there. Down around 4 o'clock, right there. That's the crescent, the little red spot.
The dark one, or?
No, right there.
There, okay.
That's the crescent.
Okay. So yeah, you can see lots and lots of red nebulosity when you just take a time exposure. This is about 12 minutes. Actually, it's 4 3-minute exposures combined. And this is looking almost towards the horizon. And once again, you can see that this tree appeared 4 times because I took 4 3-minute exposures. And once again, you can see a lot of red nebulosity. This is M8, M9, 20 and M21, M17 and M16, and they're primarily hydrogen gases.
You got two star clouds.
There's quite a few star clouds.
That's the small Sagittarius.
Small Sagittarius, and this is the Scutum star cloud. I think that's M11, I'm not sure.
Yeah.
Now, you can see that these star clouds are quite blue, but what I'm not quite sure about, and maybe somebody, I've heard a lot of theories tonight, is why there are these other colors like yellow and brown. Is there anybody who can tell me exactly why that is? Why those colors are
The
there?
gases, the various gases give off various colors. Molybdenum, oxygen, all these various elements have the, so whatever gas is, the starlight's coming through this particular gas, you get the colors.
So is this color
This is
due
the center of the
to?
Milky Way, which is quite
Yes, this is the-
replete with dense with dust and gases of all kinds, gas nebulae and all this kind of stuff, and that's why you're getting the different colors, because you're getting different elements in there.
Sure, but does anybody know what they actually are?
Well, I can't tell you you'd have to be a chemist to tell you what element gives what color.
Right.
I'm not
But
familiar
you're
with
also
that.
looking
Okay.
at the density, look at the top. You're off the Milky Way, see it's black.
This is actually, yeah, not part of the Milky Way at all. This is
You can
kind of
see
off
that
the Milky
as
Way.
the stars concentrate, you're gonna get, it's a thicker amount
Right.
of dust and clouds that you're going through.
And there's a lot of dark areas which are obviously dust, which are absorbing whatever behind
Bernard Dark Nebula,
behind them.
series of them there.
Plus,
So-
Rolf, you're tending to get more towards the center of the galaxy.
Yes, the center of the galaxy is kind of in this area here.
Yeah, and it'll have older, yellower stars.
That's right. So that's what I think. I think this yellow glow is mostly due to yellowish older stars, and maybe this kind of brownish stuff is due to a combination of hydrogen and middle stars or red stars. I don't know. Anyway, it's interesting. I did enhance the saturation on this just to bring out all the colors, because I think it's very interesting that there are so many different colors. It's almost green down here, but that might just be the tree. I don't know.
Did you have a comparison photo?
Pardon?
Did you take a comparison photo before?
Before what?
Well, before you took this one. At some time before that, were the colors the same? Or is this the very?
Oh no! If you look in books or online, all these pictures show these colors.
Okay.
They're always the same. Now this was also on August 1st. This was the sun. Did anybody see all these sunspots?
Yep.
It was quite amazing. So keep watching for what may be auroral displays. Not that they are directly associated with sunspots, but sunspots indicate solar activity, and with more solar activity you can get more likelihood of aurora displays.
Ralph, the center one there, that group in the center, that caused a flare,
Yeah,
an F
Right.
flare, I believe. Yeah, that one
There's
right
a-
there in the middle, yeah.
almost an X-class flare.
Yeah.
So this was a close-up.
3 flares coming our way now.
Yeah, so
Should have arrived this afternoon.
so keep watching for aurora.
How much closer did you have to get for that one, Rolf?
Oh, that's actually just cropped from this one. Because
Flew closer.
He was in that airplane, got a little closer.
no, I was in the same spot.
Okay.
Very good.
Okay, is anybody familiar with Alex Colville's work? For years, I've been trying to duplicate the picture the painting that he made of the cow and the full moon and the clouds. That's a really neat picture, but the cows never cooperate, so they're really far away in this picture. But
He painted it.
yeah. Anyway, I thought this was kind of neat, so I just kept taking more and more pictures in the hopes that these cows would come closer. But maybe they didn't. Do you want to click on that, and we'll see what happened? I think they went away.
Tough room.
So, oh. There you go. They went away, sadly. So we just look at the moon.
There's that same yellow effect.
Do you want to play it one more time? People want to see the cows moving in a hurry.
Yeah, but you can jump over the moon though.
You could have animated that.
Don't give him ideas.
So I'm going to keep trying. We keep trying, but the cows just don't cooperate.
One of them looked like it wanted to jump.
Thank you all. Next up, Bob Olson. Bob's Bob. Yeah, it should be there.
Yeah, this is the veil in hydrogen alpha, and I think the thing about this shot is that it's a 16 photo mosaic. I have a kind of a pathetic little camera. It takes a picture about this big, and I've always wanted to take a picture of the veil, so I managed to get my computer to actually overlay a mosaic for the veil. Now, I take 4-minute exposures, and 16 of them about an hour, and I need hours of exposure in hydrogen alpha because this is hydrogen alpha gas. So this picture should take about 2 weeks to take, and I did this in one night. So it's way underexposed, which explains some of the weird, lack of some difference in noise level in different frames. This is hydrogen alpha. This is in oxygen 3, and you can see that it's different. Different stuff shows up. How can I do that? Yeah, shows up different stuff when I do that. Same picture, and then because oxygen 3 is red, is green and blue, and oxygen and hydrogen alpha is red, I combined them, and they overlaid perfectly, thanks to Doug George's very nice software. This is a fake color. I mean, this is not really the color it is, but it's still kind of interesting. You can see the oxygen and the hydrogen gases showing up, pretty neat. And this is a massive picture. This is about 6 times the size of the full moon. So it's a very, very large area of the sky. Even though in Rolf's picture it looked really pathetically small. On Tuesday, Andre Paquette mentioned that the comet Gerard is going pretty close to M15, and so I snapped some pictures. I didn't have a lot of time on this. This is probably an hour about, and it's kind of interesting because you can start to see the tail splitting into two.
Goes up on the south.
Yeah.
That's got quite a nice 3-dimensional.
Yeah, yeah. I use a trick that I learned in the Winter Star Party. As you can imagine, the comet is moving as it goes across the sky here, and the stars, surprise, are not moving. And so what I do is I align all the pictures on the comet, and so I get a sharp. That's a real sharp image of a comet, all right. Comets are by definition kind of fuzzy, and then the stars, I do a line of picture, all of them. All the stars lined up, and then I combine the two of them to get this kind of a picture. And I had my hydrogen alpha filter in the camera, so I took the Lagoon Nebula, and it's kind of neat. I don't have a really good view straight south, and Sagittarius is so low in the sky for me that I really don't have many of that sort of bunch of stuff that's in that area. But anyway, I'm starting to collect RGB on this now, so I may actually be able to add some color to this. And here's the North American Nebula, which you also saw in Ralph's picture. This is about 7 or 8 hydrogen alpha images, and I thought it was really neat. And it's like the other one was done by a computer. My telescope is controlled by a computer. They all overlap perfectly, 20%, all nice and square. This thing is a hodgepodge thing. I aim my camera, I take a picture here and I take a picture down here and hope they would all match up when I was all finished. And they mostly did. I got the whole sky covered except for that little tiny corner right there. That little picture right there is exactly the same as this little picture right here. It looked stupid with the corner missing, so I cloned it over. But I have a tremendous amount of respect for Peter Cerevolo for doing the whole freaking sky. I could hardly do this one. I think that's it, eh?
Thank you, Bob.
You're welcome.
Last up, Gary Boyle.
Thank you very much. Just one observation taken a couple of minutes ago. First, the self-explanatory crescent moon, and this is my the vane, the weather vane from my observatory. Just a little tree next to it. But the main reason why I'm up here is that in a few months, it'll be that time of year where astronomy meets gastronomy, and the annual dinner will take place on Friday, November 18th at Algonquin College, Salon D. And I'm pleased to announce that our guest speaker will be Dr. David Saint-Jacques. Next slide. Thanks. As you can see, David Saint-Jacques is with the Canadian Space Agency. David was born in Quebec City and raised in Saint-Lambert, Quebec. He's married, speaks English and French, and pretty semi-fluent in Spanish and Chinese. He earned his Bachelor of Engineering degree in Engineering Physics from École Polytechnique, Montreal. He has a PhD in astrophysics from Cambridge University in the UK in 1998. Saint-Jacques is also began his career as a biochemical engineer and has a broad scientific background in also astrophysics and chemical training. In medical training. I'm thinking of chemtrails again for some reason. So this will be a very interesting talk. As to yet, we do not have a title for the talk yet because it was only confirmed 2 days ago that he will be speaking. So I will be taking names and, of course, payment, $42 a ticket as per always. Same buffet. Next picture, please. And next one. There we go. How many people have been to the banquet in past years? Your stomach speak for yourselves. Just excellent food. Great ice sculpture, but the hippa beef and all the again gastronomy items are just fantastic. It's really worth just the price for the food. But again, Dr. Saint-Jacques from CSA. So again, you can see me during the break. I'll be at the back of the auditorium and also at the end of the night. I have a list. I can take your name or payment now, checks, cash, not Canadian Tire or credit card. But over the next few months, I'll be collecting too. Any questions? That's all, folks.
Thank you, Jerry. Okay, one last point before the break. A couple of positions have come up as being vacant very soon. So we're just calling for volunteers right now over the next while. Both the position of astronauts editor has opened up. Deborah, I think, is moving on to some other activities in life and doesn't have the time for it. I think we probably need to thank her, first of all, for a wonderful job over the last while. Thank you, Deborah. But she leaves it in great condition, and I think it should be a nice job for someone else to take over. The second is there's also an opening coming up for webmaster, and again, I think we're in good shape right now, but our current webmaster is moving on, and we really need to have someone else step in. So if there's any interest in either of those two positions, please get hold of myself or Al Scott. I'm not sure that Al's here this evening, but nevertheless, put your hand up, put your name in the hat, and we'd be more than happy to have someone step into either of those positions.
So, for all of you who have Canon cameras, gosh, that might be wrong, for example, you might find this very interesting.
Welcome, Guylain.
Okay. Bit of logistic first.
It was working before.
What'd you do?
I don't know.
There you
we
go.
go.
There you go.
You want the handheld mic, Guylaine, or you prefer that?
I think I should be fine like that.
Okay.
I'll be fine. Yeah, should be fine. Well, again, my name is Guylaine Rochon. For those who have issues pronouncing French name, call me Bob. It's all the same. Long history short, Backyard EOS was a pet project of mine. Last year at this time, it was my own personal software, barely operational. And then probably last September, it kind of took a life of its own on a couple of web forums on the net. And long and behold, October 2010 had a beta release, and November had a full production release available for everybody to consume. What you're about to see today is a small presentation that I did in April in New York at the Northeast American Imaging Conference. I was invited by Bob Moore, the chairman, to do a presentation over there just 3 days or 4 days after the launch. Back in November, I got a call from him inviting me to go there. So everything happened kind of fast for me. I still have issues sleeping at night because this is a love for me. I first got introduced to astronomy about, I'm going to say about 5 years, give or take a year. And I did observing for about a month or two, but got drawn to imaging almost immediately, and I just never. I can't let it go. It's a disease, and there's no known cure, and I think you guys can attest to that.
I've got it.
Yeah, there's no known cure. It's you're hooked for life, basically. So this image of the sun was actually taken with Backyard EOS by one of the users, Mark Levito in New York, about 2 weeks ago. So that was taken with a Canon DSLR camera. So just a bit of historical milestone, although I did go through them. November, personal development. September, decision to make it available to the public. November, the first release, got a call from Bob Moore and Alan Treno a couple of days later. Released an update in March. I was a guest speaker in New York in April. And just a few weeks ago, I released another version with lots of new goodies in the system. What you're about to see, I'm not in here basically to get rich. What you're about to see, everything is available for the modest sum of $24 US. I'd rather sell many copies at a low price than work hard and sell one copy. So I'm
24 Canadian?
Well, I would. It's all the same. It's almost all the same. Yeah.
It's actually worth more than.
Actually, yeah. It's a decision that I made a few months ago. Well, last year, basically, to sell it in US dollars, hoping that it's going to be it's going to flip and going to be beneficial for me. But for now, it is what it is. At the end of the day, if you want to use it, there's no reason why you can't. Basically, price is definitely not an issue. I'm a software engineer by trade. To me, usability and ease of use is as important as the feature. So intuitive is basically my mission statement in trying to offer any kind of functionality in the software. So hopefully you'll find it as such. Anybody here that is actually doing DSLR imaging with Canon cameras? Okay, so that's going to be interesting for you guys. Before I get into the actual software, this is just a preview of the frame and focus mode in the system. There is a couple of mode. The imaging mode, of course, we are in frame and focus. What have I done?
It's your dark frame.
Yeah, no. I also have, where's my mouse now? Okay. And I also have the planetary mode, which basically uses live view to create short movies. That's the feature that Mike Levito used to take the picture of the sun 2 weeks ago that you just saw. He actually took about 1,000 frame in just the span of a couple of minutes using live view, and he used Registax to actually stack the 1,000 image that he got from his Canon DSLR camera. I'm not going to talk too much about that. What I'll do is I'll switch directly to the software itself. So I'm going to minimize that. It's already fired up here. I got my Canon 40D here, so I'm just going to fire it up. And if you're lucky enough, you'll be in the field of view, and it's all going to be about you. So the software automatically recognizes the camera. So it's automatically connected. I've got my camera information center here. By the way, it's all red for obvious reason, but for the purpose of the demo, I'm just going to turn on the light so that it's a bit clearer. Can you see a bit better? Yeah, okay. So I've got my information center here, giving me a bit of information about the camera, the battery level, the current ISO in the camera, the dial is set to manual, and so on and so on. I'm just going to go through the mode quickly, then I'm going to get back to an imaging session. Frame and focus actually activates live view, so that's you guys over there if you want to wave. Somebody's waving, but I think it's aiming more on that side. Planetary mode uses the same function. It uses live view, but it will create an AVI for you. And drift align, well, it uses your camera as an eyepiece with the rotatable crosshair, and you can actually drift align your mount. So the beauty of that is you can actually drift align your mount without changing from an eyepiece to your DSLR camera. So if the camera is already set there, you use it to do your drift alignment. And it all uses live view, basically.
What about cameras that don't have live view?
If you don't have live view, yeah, right now the planetary and the drift alignment will be disabled. You'll still be able to access the frame and focus mode, but you won't have access to this feature here, which is the live view. You'll be stuck taking still images, but the beauty is you can actually activate the loop, and you take one image every 1 second, every 2 seconds while you are adjusting your focus. It's not very evident here, so I'm going to minimize that and start another copy of the application. This one uses a simulator. The simulator is the same thing. It's a bit better to do the presentation, but it uses image I took with my 40D a couple of months ago. So if I go into the frame and focus, I should have a star right there. I can't remember what the star was actually. So you can basically have the crosshair on or off as you please. That's the center here. And there's the zoom box here. You can actually just zoom it a bit bigger and whatnot. What I do as well, which is a neat feature, is I plot a graph of the star in the field of view. And I also do a bit of analysis and give you the full width half maximum live. So you can actually attain perfect focus just by looking at those numbers. If you look at the full width half maximum, it's there in big, because usually you're a couple of feet away. If you don't have a motorized focuser, you're a couple of feet away adjusting your focus, and the monitor could be far off. So having it there in big numbers actually helps. It helped me. That's the reason I've put it there in big numbers. Any questions so far?
Does it work on a netbook?
It will work on a netbook. What I do is I will auto-detect the resolution. I will shrink actually I can show it. I can force it just to give you an idea of what it's going to look like. I believe in settings, I'll get to that later, but netbook resolution, this is what it will look like on a netbook. Basically fitting on a resolution of I believe it's 600 by 1024. You don't miss much. Basically, you don't see the text that's displayed here, but the text doesn't give you any functionality. The only functionality that is different is in imaging mode. Instead of displaying the histogram there in place, you need to click a button to see it. I just had to make some space. But yes, just to show you, I do support netbook. So I'm just going to put it back to It's the real size. So it's. But if you're on a netbook, you don't have to do that. I will automatically detect the resolution for you and do that for you. Okay, so I'm going to move back to the real camera. So that's the 40D there. Some users actually want to focus on bright object. Let's say you're imaging the moon or whatnot. The moon is pretty bright. Full width, half maximum is of very little use when you're imaging the moon, unless you're focusing on a star, then slew back to the moon. What I do is you can activate the standard deviation, which is a different algorithm on the entire image, and you can use that to focus. It works similar to using the full width half maximum, except that instead of focusing with the lower feedback, you focus with the higher feedback. Still operates the same. When you get the higher number, you're dead focus, basically. So, let's go to the imaging mode. So the imaging mode, here you've got your capture plan. You can select the type of frame that you want. Selecting the frame that you want doesn't do much other than tagging that particular label to your image name. And a few more things, but basically it's just to put the imaging name. Support several cables, especially if you've got the older Canon model, like the 20D, 30D, 350D. These cameras uses the Digic 2 processor, and you cannot achieve bulb over regular USB cable, so you need a serial cable, and support the popular shoestring, and then any homemade, homebrewed serial cable that you have should work if wired properly. Target name, I'm going to write my name. Obviously it's Bob. And here I've got one exposure, bulb, duration 1 second, ISO 1600. None of those numbers here are predefined. I actually read what the camera is capable of delivering, and that's what I show here. So if I would plug another camera that I have here, 1000D, I'll get what the 1000D publishes in terms of its capacity or its capability. The same thing with the shutter. I actually give you, because I've got a lens installed, I actually read what the lens is capable of doing, and I will actually give you all of the f-stop. And if you go down, I will actually publish all of the TV value as well. So you've got full control over what kind of images you want to take. So I'll just take a bold picture of 1 second. So there's the image. Anybody? There's no moving cows in that one, so. I can't believe I just said that, but anyway. Long story short, this is basically a one-to-one. I can view the entire frame if I want. And if you want to see everything in big, then I can. I've got a presentation mode, which basically uses the entire screen to display the image. You can also put a grid. Sometimes it helps if you want to do your framing. If you've got a previous image and you want to frame your current session with an image from an older session, you can actually load an image from a previous session and overlay those images and actually frame your second session with the one you did last night to make sure that they're roughly well aligned and get the same field of view for your stacking. Not sure if you've seen, but look at the image file name here. Pretty long, right? It contains the name of my target. I'm imaging Bob. I'm hoping Bob is in there somewhere, Bob Nebula. And then follows by light. This is a frame light. It was 1 second, ISO. Because I've got a lens, I've got the f-stop there. I also calculate the standard deviation of the image on the fly. It could serve as the night goes on to see if you're moving out of focus and whatnot. So if you see a big variation in the standard deviation, it means that there's something different from your first image or images early on in your imaging session. And then of course the timestamp. This is the default naming schema, but you can change it basically. Just to give you an idea, if I go into settings, file name template, I can actually change whatever it should look like. And you can select from a lot of predefined value, the temperature, the duration, change the order. Basically, my style is probably not your style, so you make it up as you go. Histogram, kind of a basic there. Both luminosity and RGB are being displayed. EXIF data. I automatically read and add EXIF data to all images. Basically, I'm giving you a couple of data that is not there. Full width half maximum, I actually calculated the full width half maximum of the image as well. Giving you standard deviation calculation. I'm giving you the target name in the EXIF data. So if you're computer savvy and you are used to extracting that data, then you've got additional metadata information in there. One that's pretty neat here is the weather, the current weather. Not sure if you've noticed, but there is a weather center here. I have a little device here. It's just a USB, what it's called a temper, and it gives me the temperature and the humidity, and from that I basically calculate the dew point. I also put that information in the EXIF file of all of your images if you have it. This is not the only unit I support. I also, if you're on the internet and you've got access to the internet where you're imaging from, I can also feed from Yahoo Weather and get the information from there, from the RSS feed. Or if you have a personal weather station that can spit out a text file every 1 minute with the local weather, you can also use the system to configure it to the type of file that you have, and I'll read the data. I'll display the data live here, and the data will also make all its way through into the EXIF file. So that's pretty neat, basically, if you want to keep that information. So if you can see, the weather station basically disappeared because I took it out. Within a minute or so, it'll read it again automatically, and it will show up. I only took one image, but basically I can increase that to take me 6 images of, I don't know, 200 seconds. Oh, that's not a nice number. 300 seconds at ISO 1600. Put a pause of, I don't know, 30 seconds after those images to let the sensor cool down or whatnot, followed by 10 images of bulb, and let's say I want to take different ISO 800. So you basically create your session plan, and then you leave. And if you're not sure when to come back, I'm going to start that plan, and it's giving me an estimated time. According to what you've just told me, this session plan should be done at 11 o'clock tonight, just past 11. So go away, come back, and you'll have a couple of images all downloaded to your computer with the proper name. So I'm going to stop that one. Obviously, I don't want to be here till 11 o'clock. Yeah, okay, so it's oversaturated, of course, because, well, I took a whole 22nd of it, actually. There is a loop feature here. The loop feature is particularly good if you want to take images, let's say, of a lunar eclipse, where you want to take a couple of images at different f-stop and then just cycle through those images as the eclipse move on for a couple of hours, an hour or two or whatnot. So you can actually program it to take one image at f4, different TV value, and then followed by another short image a few minutes later, and then so on, and then just let it rip for an hour or two during the eclipse, and at the end of it, you've got all of your images. So pretty neat for that. Questions so far?
I have a question.
Shoot.
On your live view video capture, can you do an ROI and raw frame?
What do you mean, to take a raw CR2 image right from the planetary mode?
Well, the planet is small, so you don't want to do the whole frame. So
No.
ideally, you just want to capture
The camera, look, the camera provides a function to, you know, on your DSLR camera, you've got the 5x zoom and the 10x zoom. The 5x zoom is actually exposed to the SDK, so I have access to it. The 10x zoom is actually just a 100% crop or a crop of the 5x, so there's no real advantage of using that. But yeah, that's
So
that.
you've got the 5x, which basically captures 1/25 of the frame.
Exactly. So I'm going to position the box right here, double click, and that's basically what's in the middle here. And that's where you would, so that's what you would basically do.
And would that be in RAW?
No, that's a live view feed. So
Right, so you have to capture compressed?
I actually create an AVI file, and I'm using a codec to compress it. Yes. But it's a regular codec, and the only reason I'm using a codec is for the file size. Otherwise, if you take 1,000 frame in just a few minutes, it's going to eat up your disk space. But the codec I'm using does not take away any quality, so there's no difference in using it or not using it.
Which codec is it?
Oh God, I like to look at my code. I would, if you post something on my Yahoo group, I'll definitely answer you within 24 hours with that codec. Definitely. So I'm just going to move away from that zoom. Any other questions so far?
Another one? Yeah.
Yeah. Okay.
Which OS do you support?
It's a .NET application, so basically it runs under Windows. If you've got a Mac, the only alternative right now is to run under Parallel or VMware, which runs Windows. It runs on XP, it runs on Vista, and it runs on Windows 7. The only exception is the older cameras, basically the 20D, 30D, 350D. These cameras, Canon does not provide any drivers for Windows 7, so you are limited, not by choice, you are limited to XP or Vista for those older cameras. Other than that, they work on Windows 7. I've got Vista right now running on my laptop.
So the PhD guiding icon. Talk to that.
What was that?
Is that PhD guiding icon?
PhD, well, it's Greg Stark. It's written in C++. And having it written in C++, he can actually compile it for both Mac and Windows. That was a design decision that he made. Mine was different.
Yes, sir. No, I mean, I thought I saw the PhD guiding icon on your screen.
Yeah, okay, sorry. What I do as well is interface seamlessly with PhD, Push Here Dummy, which is the guiding software, to actually dither between frames automatically. So if you're using PhD, Greg was good enough to actually open a port in TCP. Actually, he did it for himself because he wanted to do the exact same thing with nebulosity, but by doing so, he opened the door to everybody else out there. So what I do is, in between each images, I will actually talk to PhD and tell it to do dithering. And I will actually report the progress of that dithering inside the progress wheel here. And once dithering is done, PhD actually confirmed that it's successful, and I take that reply back, and that's my cue to resume imaging with the next image. So if you use PhD, I do at home, and I definitely do dithering. It moves everything, and it doesn't replace taking your dark frames, but in addition to the dark, dithering is an awesome way to reduce noise in your final image.
What's PhD?
Push Here Dummy. Seriously. It's a guiding software created by Craig Stark. That's the name, Push Here Dummy. Yeah, I'm not kidding. So that's the guiding software. It's free, so there's no cost to using PhD. If you've got a guide scope and a small CD camera not doing anything good enough for guiding, then take full advantage of it. Without guiding, you'll be stuck taking images with a DSLR. 30 seconds, you're pushing it. If you've got a good mount, you might be able to go to 2-3 minutes, depending on the type of budget. On my budget, the more I could do without guiding was about 90 seconds. And at 90 seconds, I had about 50% of my frames that were throwaway. It just wasn't good. With guiding, I can easily get 10, 15 minutes. Yes. Okay, fair enough. So I've got 5 minutes. No moving towels, I promise. Okay. So the planetary mode basically works the same. You can actually adjust the ISO, the TV shutter, especially if you're imaging the moon. It's pretty bright, so you would want to dim it out a bit. I can dim it just here. I'm just going to reduce the ISO as well. So you're dimming it as much as you want, and then the default is 100 frames. You just click record, and it's just going to go through it, and it's just going to capture, it's pretty slow on that laptop, but it's just going to go on and capture X number of frames, and once it's done, you're going to end up with an AVI that you can then use to stack with, it's pretty slow on that laptop actually. I'm going to abort that, and then I've got an AVI created basically. Okay. Under settings, I'm gonna, since I only have a couple of minutes, I'm gonna give you basically a couple of pointers in terms of what you can do. Images by default are stored to the computer. You can actually store it to the card as well. Quality, you can select RAW or JPEG. The default is RAW. Why? Because I've made the mistake so many times to forget to actually set the camera to RAW, and I ended up with JPEG images.
Yep.
I'm sure I'm not the only one that made that mistake. And then this is your configuration basically for PhD guiding, where you can actually activate it automatically. There's a couple of configuration that PhD allows us to pass to it, so I take full advantage of that, giving you full control of what you're trying to accomplish. Not that it really matters here. You're either French or English, probably English, but through the generosity of users around the world, the application is available in a couple of different languages. And I'm told Italian is the next one on the list from a couple of users. Mirror lock. A lot of cameras, DSLR camera, have the mirror lock function, but that function is very hard to get at from the Canon SDK. Which is the reason why you need a serial cable to activate mirror lock. For those that do not have a serial cable, I've got a virtual mirror lock function inside the system. Basically, if your camera has live view, I will use that functionality to flip the mirror a couple of seconds. You decide how long before the actual image takes place, and that basically eliminates any vibration caused by the mirror flip in the camera. It gives you a couple of seconds, 10 seconds, depending on your setup. You just configure the time frame, and basically any vibration caused by the mirror are not part of your image because there is that time frame before the actual image takes place. On the downside, when the mirror is up, the sensor is heating up. So you want that long enough, but not too long. And that's usually useful for short images. So if you're taking images of the moon, usually short in nature, the mirror flip of inside the camera can actually have an impact on your image. So mirror lock is a useful feature. Again, you need a serial cable in addition to just a regular USB cable that came with your camera to activate the in-camera mirror lock. But if you don't, there's the virtual mirror lock, which is an experimental setting right now that I've just published in the last release. Pending real testing from real users, it will make its way through the application itself. I think that's about my time. Again, everything you've seen here, 24 bucks. I'm not here to make money. I'm just here to share my love of imaging. It only works with Canon, not Nikon. That's just the way it is. I've been asked that question, so might as well put everything on the table now. So again, thank you for having me. It was a pleasure.
Our last presenter for the evening will be Mike Mogadam, who's here to tell us about his observations of STS-135. Welcome, Mike.
Well, hi, everyone. Back in early July, my family traveled to Cocoa Beach, Florida to witness the launch of STS-135, which was the final mission of the shuttle program. I'd like to share with you a personal account of the launch, along with some background on the mission, and finally some exciting pictures and some videos, one of which was taken by my son. And I'm really excited about seeing it tonight. So first, a little bit of background. STS-135 was the final flight for Atlantis, but also the final flight of the shuttle program. So I was, for years and years and years, I was really keen on seeing a liftoff. And when this came up, we said, "That's it. We gotta do it." So after, it's hard to believe, but after 30 years, the fleet of reusable low Earth orbit spacecraft was finally being retired. And think about it. It was back in. I did a bit of research for this presentation. It was back in April 12th, 1981, when the first one went up, STS-1, which was Columbia. So that's amazing. So STS-135, as the name implies, was the 135th shuttle mission, and it was the 33rd flight of Atlantis and the 37th shuttle mission to the International Space Station. STS-135 was really never meant to happen. The flight was originally planned as a launch on need, as they call it, mission, meaning a rescue mission for STS-134. Which at the time was the last scheduled launch, you may recall, back in the May-June timeframe. So the way it happened was that special funding was authorized through a U.S. Senate committee back in July 2010, and for one more mission after STS-134, and so STS-135 was born. So what were the mission objectives? Well, there was a couple of them. One of them was that there was this Raffaello, it was bringing into space, in fact, bringing into the ISS, this basically this cargo carrier, this Raffaello multi-purpose logistic module, which you can see it's in the belly of the, or inside the, it's that little cylinder in the back of the opening in the shuttle there, and it actually, there's another picture on the bottom of the screen there that shows what it looks like. Now, actually, that wasn't the first time that carrier has been taken into space here, but it really, what it is it just carries, intended to carry 1 year full of 1 year's worth of supplies to the ISS until the commercial cargo resupply system is up and running. And altogether, it contained 15,000 pounds of cargo of food and clothing and spare parts and all sorts of things for the current and future ISS crews. It also carried a robotics refueling payload. There are many names for this, but really what it is it was a system designed to demonstrate the technology for refueling satellites in orbits remotely by way of robots and so forth. So the idea here was that as a proof of after this proof of concept, after this demonstration, NASA's goal was, or I guess is now, is to transfer this technology to the commercial sector, and also picked up and returned to Earth a failed cooling pump that was temporarily stowed outside of the ISS by, I think it was STS-133, and it required actually a spacewalk to go get it and retrieve it from the outside of the ISS and bring it back to Earth. And by the way, there was one other thing that is not well known. It actually carried a little they called it a small satellite, a Pico satellite solar cell, into orbit as well, a very small one. It's interesting to note that STS-135 did not have a backup shuttle on standby in case of an emergency, like 135 was to 134. So in the event of a problem, the line goes, the shuttle astronauts would remain on the space station and then ultimately return to the Earth aboard a series of Russian Soyuz spacecraft. But obviously the trouble with that logic was that the shuttle would have to reach the space station in the first place. So we toured the Kennedy Space Center a couple of days before the launch, and we had planned to do this because we had heard that the shuttle would be already on the launch pad, on the launch site, and we were really keen to see it as close up as possible. So here's a photo of my son, and with Atlantis on launch pad 39A in the background. So the Space Center, the Kennedy Space Center bus tours actually took me closer than I expected, and between this viewing site, going to and from this viewing site, they actually take you much closer, which really surprised me. So in this photo here, you can see the two white solid rocket boosters, and of course the big orange external fuel tank. And I figure that it's about 5 to 6 stories in height from the bottom of the solid rocket boosters to the tip of the external fuel tank. Now, obviously, the propellant inside the SRB, the solid rocket booster, is indeed solid. I'm told it has the consistency of a hard rubber. And obviously, once the solid rocket boosters are lit, or once they're started, there's no easing off on the throttle. Once they go, they go. They burn to completion. Each SRB burns nearly 5 tons of propellant per second. It just amazes me. It's hard to believe that the SRB tanks are actually reusable. So once they're you've probably all seen photos or videos of them jettisoned from the shuttle, and eventually they parachute into the water, are picked up, retrofitted, and on to the next flight. Just really truly amazing. The external fuel tank is different. Obviously, the orange one there attaches to the belly of the orbiter, carries 1.3 million pounds of liquid oxygen and about a little less than a quarter of that in liquid hydrogen, and for the 3 liquid-fueled engines at the back of the orbiter. That in itself, it's jettisoned and it's not reused. Now, unfortunately, in this photo here, the Atlantis orbiter is behind the fuel tank, so perhaps you might be able to make out, if you you almost have to imagine a bit of a dark outline, which is the orbiter again behind the tanks there. So one thing I want to point out here is you may recall in an earlier RASC meeting that John Wayne Ross took some photos, probably from the very same location, and he had talked about an escape line. Now you can see there's a sort of faint wire off to the right there. The idea behind that, just you may recall, was that there's a little. Is there actually a laser on here?
Yep, center button.
The center button. You can see the little basket right there, and of course the wire there. So the idea here is if there was an accident or some sort of impending explosion, the astronauts would walk across, or imagine run across, and hop into the basket. And this line extends down a quarter mile, and by the end of their journey along that wire in the basket, they'll reach 55 miles an hour. And there's a cement bunker that they would hop into and go underground, and hopefully all before you're. Otherwise, they'd be blown up into smithereens if they didn't reach it in time. So it's very risky, and the speed that they would travel down is quite fast. So it's really hard to appreciate the size of the shuttle. So I hope the next couple of pictures will show it here. So here is the crawler that you see parked off to the as we're taking the bus tour off to the side of the road here. And the crawler's function, I'm sure most of you know, is to move the NASA space shuttles, complete with the launch platform, as you'll see from the big assembly building, the vehicle assembly building, up to the launch pads. It's hard to grasp the sort of the sheer size of this. It's unloaded. It weighs 6 million pounds. It has 8 tracks that are on 2 tracks on each corner of this rectangular assembly there. Altogether, each crawlers pack over 5,000 pounds, 5,000 horsepower. Top speed is only about 2 kilometers per hour. When it's fully loaded, there's 11 people that need to drive this, and something like gas mileage is 350 liters per kilometer. Now the Space Center has been using 2 crawlers, and nicknamed Hans and Franz, since their initial delivery back in 1965, and these have been real workhorses in their lifetime. Apparently, they've traveled more than 3,400 miles, so quite a thing here. So here's the roadway for the crawler here, and you can actually see some tracks here, and a pair of wheels on one side go on this gravel road here, then the other pair on the other side here. This is big. Now, obviously, it's not cement or asphalt, but I can't remember what the composition was explaining, but this goes quite deep. They've really made it some foundation for this here. So let's look at the crawler equipped. So here's a photo from the June 20th APOD that shows the shuttle now on top of the crawler. You can, in fact, see the launch platform here. So it's obviously right below this is it right here. It's below and of course the crawler on the bottom, right below the tanks and the bottom of the tanks and so forth. So they move the whole kit and caboodle. It's quite something here. And by the way, the other thing I didn't realize here, because I wasn't sure if we would actually see this on the launch pad or not, but apparently it moves the shuttle. They move the shuttle several weeks before the launch, and that's done to allow sufficient time to check for cracks and other things that might be damaged in the travel. So, and they wanted to have enough time to thoroughly inspect it. And a couple of days before the launch, if it looks like there's a possibility of a launch, they fill up the tanks, they gas her up, and then they go. Okay, so on to the launch. We drove into Cocoa Beach, which is a surface town on the Florida Space Coast, the day before the launch. So the streets were filled with cars and a long traffic jam, and it was obvious why there were so many cars here. And to be honest, I was a bit anxious. I wondered if we'd really be able to find a spot to the view of the launch. There were just way too many people. All the hotels were filled to capacity, and it was apparent that something big was going to happen. Wherever you went, the subject was the shuttle program, and really the ending of the shuttle program and the launch. Radio, TV, newspapers, it was always all about the shuttle. And it was interesting because in our hotel room, the local cable actually carried the NASA channel, so as part of the mood, I had it on almost all this every time, whenever I was in the room. So in the day before the launch, you may recall the weather forecast was pretty gloomy. There was a 30 to 40% chance of clouds that would delay the launch, and the thing that was a little frustrating was that there was wannabe meteorologists everywhere you went, everywhere you turned, who were giving they're sort of forcing upon you their view of the gloomy forecast and how it would be delayed, and here I am going down there to see this once in a lifetime experience, and I didn't want to hear any of that. So I had prepared myself. We did prepare ourselves for the possibility that it wouldn't happen, but we still kind of booked a couple of extra days in the hotel, hoping that if it was delayed, we might catch it the next day and so forth here. And by the way, I had learned that the Atlantis had a launch window, by the way, of only 10 minutes. Okay, so any delay beyond 10 minutes, for whatever reason, would require the launch to be postponed about 1 day. Now specifically, the launch would be postponed by 23 hours. Okay, if there was something that caused a delay, and the reason for that was that 23 hours later, the ISS would be in a favorable position for the shuttle to meet it. So if a third attempt was necessary, again, another 23 hours. Would have to pass. And by the way, with each of those iterations, the weather would have to cooperate as well. So it was kind of like rolling the dice, and I knew that, and of course all these meteorologists again. So I figured the area hotels were probably the ones that were praying for the opposite. They were praying for the launches to be delayed. Now initially with the announcement of the STS-135, area hotel prices skyrocketed. We paid $285 a night, $285 a night, and I had heard that the regular rate was $85 a night. So clearly, this was an economic bonanza for them, and they were milking it for good for them for what they could. I went to bed the night before the launch with really an alarm clock in my head. There was no way, absolutely no way, I was going to miss the launch the next day, even if it was at 11:29 the next morning. So I had this thing going on in my head throughout the entire night. The morning of the launch, I was a bit paranoid. My head was filled with once again memories of the traffic jam from the day before, and the prospect of not finding an observing spot. And I was worried that I might miss out on something that I've been wanting to see for my entire life. So I arose just past 6 a.m. and headed to the beach just outside my hotel, not knowing what to expect, not knowing what crowds would greet me on the beach. And as I rounded the corner and walked out to the beach, what did I see? Lo and behold, in front of me, one lady doing yoga. So there was no one else around. So I was kind of filled with both satisfaction that I had made it, but not having much sleep either. I was also filled with a bit of uncertainty that maybe I was at the wrong beach. So maybe I worried too much. So I was determined to hold my spot. So I unrolled my beach blanket, kicked off my sandals, and pulled out a book with pen and paper to record my observations. The sun had just risen, and the temperature was already warm. There was diffuse clouds in the sky, and it was really hard to predict what would happen that day. There was a steady breeze from the south, and really it was an idyllic scene with a seagull held motionless in the wind, and in the distance they had these pelicans that were swooping down across the wave tops like pterodactyls searching for food. It was hardship for me, I tell you.
Beautiful picture.
Yeah, thanks. So while the blowing wind and crashing waves were sort of lifted up the beach sand, I could still see in the distance one of the Kennedy Space Center launch pads, specifically 39B. Now, I may remember earlier I was telling you that Atlantis was going to lift off from 39A. The giant, venerable vehicle assembly building was a bit further away, a bit to the west. It was really truly like a giant monolith standing alone, and that was easily visible. And so if you've been down to the Kennedy Space Center, you can see that for miles and miles around. I didn't bring anything with me to the beach, no watch or iPod or anything electronic. I was sort of an unfamiliar place, and security was on my mind. So, and I badly really wanted to know the time, or at least how much longer before the launch. And in hindsight, I guess I really didn't need to worry about that, because in a few hours, the beach, I would soon see the beach would be flooded with people with iPhones and other smart devices. And amazingly, I had learned that the beach, there was a Wi-Fi signal on the beach, and soon we would have a steady sort of ticker tape of news providing every sort of detail you would want on the launch. But I did have an idea on how to keep track of the time. I stuck my pen in the sand, tilted it a bit, and ticked off the shadow of the tip of the shadow, or the top of the shadow was cast. And I figured that the idea there was that as the sun moved across the sky, it would extend an arc, and that if I recorded sort of 2 tick marks that were about 15 degrees apart, then 1 hour would have passed, and since my 6 a.m. start and all would, and I'd be able to track time. Well, things didn't work out so well. A couple of reasons. One of them was I was only a couple of degrees above the Tropic of Cancer, and the summer solstice was just a couple of weeks behind me. So the sun didn't exactly come up in an arc; it actually came straight up, and my shadow became quite a bit shorter. And I thought to myself, "Dummy, you should know that before a little bit of arc appeared." However, something else happened next that was even more unexpected. A man stopped to talk to me with his 2 sons. I guess I was wearing my Skywatcher hat, and he asked me if I knew, and he asked me if I knew where the shuttle would lift off, and it was a bit frustrating because I explained to him that I had heard that the shuttle would lift off over there in the distance, and over there in the distance, and over there. So I didn't know the area, and I heard too many different explanations or where we lift off. So I told him essentially kind of over there, but. After 10 minutes and sort of a pleasant conversation with his 2 sons, he left, and when I looked down at my beautiful sundial, I was horrified. Sundial, I was horrified. It had been completely obliterated. So what remained? Only many small footprints. So the boys have been pretty busy. So bad design onto something else. Okay, so in time, the beach did fill up with people. All the chairs people were sort of planting in the sand were oriented away from the water toward where everyone thought that the shuttle would launch. And I was thinking to myself, was this groupthink? Could they all be wrong? I didn't know, so I followed suit and faced the same direction. My son soon arrived with his camera and all his electronics, and we were once again connected. Now it was interesting because we soon saw first 1 and then 2 more later on, helicopters flying along the beach just offshore, and they were flying only about 100 meters off the water. And there was some sort of gunnery on the sides and on the front of the helicopter. And I looked really closely. I thought, okay, that's got to be a long sort of pedostatic tube, except that it was quite clear that it wasn't measuring air pressure and it wasn't determining airspeed or flight speed. It had an entirely different purpose. So obviously these helicopters were connected to the launch and were there to convey a message with their low-level flight. The message came across pretty loud and clear. Off to the south, an opening appeared in the clouds, and it was heading to the launch site. We all started to get very optimistic because this was happening about 45 minutes before the launch. The beach was really starting to fill up now, and the excitement was growing. People were, as I said earlier, were relaying the latest updates from NASA with their smartphones, and as we got closer and closer to the launch time, the announcements came out more frequently. First, someone said, 10 minutes to launch, followed by 8 minutes to launch. Then someone else followed and said, 11 minutes to launch. So it was great. It was, in spite of it all, it was somewhat reassuring. Okay, so now the beach was very busy. Okay, I noticed that people were on top of surrounding buildings chasing after the perfect view. You'll see that in a shot I have later on. I also noticed construction workers on top of extended cranes because there were some local hotels that were being renovated. They had a terrific view, I'm sure. So now it was an entirely different scene on the beach, much different from the tranquil one I encountered at the beginning of the day. With a minute to go before the launch, I started to hear an audible countdown. People were getting more synchronized in their countdowns. By 30 seconds, people stopped counting down, and heads were turning left and right, scanning the horizon. Now, I later learned that the countdown clock had stopped dramatically at 31 seconds. An alarm appeared that a liquid oxygen vent arm had not properly retracted and latched. And to investigate this, apparently there was a closed-circuit camera that was set up. The NASA engineers looked at did a visual check. All was well, so the countdown resumed. But so there was about a minute or so we were kind of going, what's going on? Okay. In my head, I could almost hear the famous drum beat of the NASA announcer's voice. You know, T minus 9, 8, 7, go for main engine start, 6, main engine start, 5. The launch came unexpectedly. Twin flames, 1,000 feet long, extended from the solid rocket boosters. 4 million pounds of propellant from the solid rocket boosters gave rise to greater than 7 million pounds of thrust. First the SRBs, then another push from the external fuel tank, and then finally the orbiter itself. In a span of 8.5 minutes, the shuttle would reach an orbit attaining a speed of 17,300 miles per hour, almost 28,000 kilometers an hour. It truly is hard to fathom the acceleration forces that the astronauts faced. The crowd on the beach, as you'll hear in the videos, just truly exploded when they saw Atlantis. Everyone started cheering, clapping, jumping. Even as I talk about it, I feel the energy of that day. There was a woman beside me who was really overcome with the moment. Her eyes welled up with tears. And seeing that, I started to appreciate the enormity of the moment. I was really proud of the fact that I brought my sons to witness this history being made, and even though I wasn't personally connected, obviously, to the shuttle program, I did feel proud of what I saw. I didn't expect just how quickly the shuttle would move. I only saw it for 30 seconds before it entered the clouds. This shot here was about 20 kilometers. This observing spot was about 25 kilometers away. It really was moving faster than anything I'd ever seen in my life. We saw it punch through a top of a cloud layer before entering another one, and then it was lost into the sky. After the shuttle disappeared, people started to come together and share stories. And my son attracted a lot of attention with his video, which you'll see. And it was one of those moments really you don't forget. It sort of burned into your memory until the last day of my life, when first the enormity of the launch, and then people coming together with perfect strangers coming together and sharing something special, something that we all had in common. Something else happened, which was really unexpected for me. After about 60 to 90 seconds, a rumbling sound could be heard. First, I thought it was the sound of the waves that were crashing into the beach, but it was louder, and it did not have that regular repeating sound. I realized that was the launch sound of a sound wave reaching us. The rumble was so forceful that you could feel it in your head. Now, I sort of went through a math calculation of 1,100 feet per second, how many, the distance and so forth. It seemed to line up with 60 to 90 seconds. That was really cool to hear that. 20 minutes later, the crowd dispersed, but I was still too pumped, okay, to sit still. I found my iPod, and I was quickly sending off a few emails, including the one that I sent to the RAC members list. After the launch, I watched a NASA post-launch briefing and learned that NASA sends up a meteorologist in a jet to get a first-hand look at the sky up close. And the NASA administrator said in the conference, he explained that the meteorologist was a former Marine who was a highly trained professional. Now, apparently the Marine's professional assessment of the sky there's a really, really big hole in the clouds. So everyone really cracked up when they heard that. So everyone was really excited for this opportunity for the shuttle to actually go up. It's funny, the opening in the clouds really didn't line up with the launch site, although the clouds did sort of thin around the opening. NASA has this rule that launches will not happen if the clouds are lower than 8,000 feet above the ground. So when the launch did happen, the clouds were at 7,000 feet, but with an estimated 1 million people on hand to watch the launch, and the largest ever media contingent since the days of the Apollo missions, about 1,500 media, I think NASA was under some pressure to go with the launch. So I learned, by the way, that rainless low clouds really don't present a problem for an ascending shuttle. The problem really is with low clouds is that they impact what's called a RTLS abort. This is a return to launch site abort. So if a return to launch site becomes necessary for whatever reason, the low clouds would really hide the runway and make the landing more difficult. Now, lastly, the one thing I want to say before we go to the videos is that another curious thing I heard in the post-launch media conference that really piqued my interest was a NASA administrator said there was an alarm that had turned on just into the moments into the launch. It's something called a DPDT alarm, okay, delta pressure over delta time. So this was due to a rapid change in the air pressure over time inside the shuttle. Now, according to his explanation, the tremendous G-forces changed the shape of the orbiter, causing a change in the internal pressure. I find that a little hard to accept, his explanation. Maybe the air itself was being pulled downward, like astronauts being pulled into their seats. And that sort of seemed a little bit more plausible. But regardless of the explanation that you choose as to why the alarm went off, you get a feeling that space travel is a risky business. So with that, let's take a look at the two videos. Is there sound with this?
Yep, should be.
Oh, I got to stop this. So I'll say a couple of things here. So you can see one of the cranes there. You can faintly see the people at the top of the cranes. You can also see on the right-hand side of the building there, there was a lot of people sort of standing there, and almost to the point that you'd think if there's any more people standing, the building would start to tilt. But you'll... We're ready to go? Okay, terrific. Again, about 1,000 feet long, the flames. So it truly is, one heck of a push. It's pure thrust. Then the next one here, do I just press the button again? Yeah. So the next one here is the last thing I have to show you here is that everyone says that no matter what photos you take, no matter what videos you take, NASA will do, the Kennedy Space Center will do one better. So there's a couple of really awesome videos on YouTube that was posted by the Kennedy Space Center. And in this one here, if it doesn't rattle your bones, nothing will. Let's go to that. So really, that's all I had to share. I hope you enjoyed it, and I really hope you have the chance to see a launch with either an whatever it's called, the X plane or whatever it is, or because the Kennedy Space Center is still active. In fact, today they launched the Juno, I believe. But it's an awesome experience. Thanks, everyone.
Okay, I think we're going to skip forward since we're running a bit long tonight. So maybe you could just flip past that. Okay, so just a few last items. Estelle's pick of the month for the library, Chasing Hubble Shadows by Jeff Kniepe. Recommend, if you haven't looked at it, maybe take a look at it. I believe the library will be open this evening. Okay. Next, please. Okay. I'm trying to remember this one. This was sent to us by, remind me? Chuck, yes, that's right. Chuck has to do with a talk being presented on Saturday, August 6th. I guess that's tomorrow. Okay. Fox and Feather Pub, Elgin Street at 1 p.m. So those of you interested might want to write down that information and go on down. Should be pretty good. Next, please. Okay, afterward, as usual, the library will be open. I don't believe Al is here this evening, so no access to the equipment loan library tonight.